Maria Liakata. Is Maria?
Hello.
Hi, Maria. Hi. Maria is going to give us the second talk of the day, which is about creating time-sensitive sensors from language and heterogeneous context. Maria Liakata is a Turing AI Fellow. I'm not going to say all her CV for time. And she's also a professor in NLP at the School of Computer Engineering and Computer Science in Queen Mary, London. She's also the recipient of one of the 5 Turing AI Fellowships on the topic that she's going to talk today. So without further ado, Maria, please go ahead.
Thank you very much, Sophia. I'm just checking, I'm sure that I'm showing the right screen. Hold on. Okay. Can you still hear me?
Yeah,
hello?
we can hear you.
Yeah,
we can hear you. Just share your screen so we can, yeah.
Okay.
Okay, super.
You can still see my screen?
Yes.
Yes, we can. Yeah, it's fine.
Okay.
Okay.
And still good? Yeah.
Yes.
Thank you very much for the introduction, and thank you very much for inviting me to speak at Advances in Data Science. I will talk about my fellowship on creating time-sensitive sensors, and I will basically present the goals and objectives of the fellowship and also current progress made in the area of the fellowship. So let me start first by introducing the area and the goals of the fellowship. So as individuals, we continuously produce large amounts of digital content, and this can be textual data in social media and online platforms, but also language and other data from devices such as computers, mobile phones, fitness devices, and so on. And we call all this data heterogeneous user-generated content. And all of this content contains behavioral cues. And so through this fellowship, what I want to do is create models that capture changes in individuals' language over time. And I call this personalized longitudinal natural language processing. And I want to develop sensors for capturing digital biomarkers from the language and other heterogeneous user-generated content to understand the evolution of an individual over time. And I call these time-sensitive sensors from user-generated content. Somehow, yeah. And while these methods can be applied to a number of different areas, I want to apply this technology to make a significant contribution to mental health by creating new tools that will be based on the time-sensitive sensors and make it possible to assess and monitor conditions in between clinician appointments and when access to mental health services is limited, such as is the case with the current pandemic that we're experiencing. Next slide. So what is the motivation behind creating these time-sensitive sensors and why are they important? So the focus on mental health is important as, according to the World Economic Forum, mental health disease accounts for 35% of lost work output, which is twice as much as cancer and more than cardiovascular disease. And there is work at the intersection of NLP and mental health that shows that signals for the diagnosis of certain conditions can be found in language. Recent work has also shown that increase in emotive content in social media coincides with increase in incidence as recorded in mental health records. And increasingly, the clinical community are looking for new and better diagnostic measures and condition monitoring tools. So this is especially the case with the current situation where regular mental health service access is reduced. And by creating these time-sensitive sensors, we can employ them as the basis of new clinical assessment tools, and we can also help online platforms with moderation activities and help them to better protect vulnerable individuals. I have two particular use cases in mind for the technology proposed. One is identifying changes in cognition and the other changes in mood instability. So for cognition, imagine that your computer has an application that allows it to track changes in your language use over time and is able to present you with evidence that there is sustained change in your linguistic ability. Or imagine you have bipolar disorder and that your device, your phone or PC, can combine your written, spoken, and other digital user-generated content over time and create a timeline with supporting evidence that alerts you or your doctor or other individual you choose that a manic or depressive phase is coming up. So how does all this work that I plan to do fit in the context of natural language processing? Within NLP, we've made a lot of progress, especially in text classification, but also translation and generation tasks. However, we still have some important missing elements. And this is dealing with small and sparse data, transferring knowledge across domains, and incorporating background knowledge or linguistic structure in our models, understanding what different architectures can and cannot learn, and having interpretable symbolic representations, enable better collaborative human-machine process, and finally, resolve complex linguistic phenomena such as ellipsis or bridging. So 3 out of the 4 I mentioned here are definitely phenomena that we plan to deal with in the fellowship, and hopefully we may also get to look at the resolution of complex linguistic phenomena. So what do we need methodologically in order to achieve these goals? So one major objective is to be able to create time-sensitive unified representations of users through their heterogeneous user-generated content. And typically in natural language processing, we create representations of words or sentences, and we have a word in a sentence being represented a vector, and we learn these vectors through word embedding techniques, and the resulting dense vectors are fed into various neural network architectures for different tasks. And typically we learn these word embedding vectors through variants of the skipgram method, and more recently we learn context-aware embeddings using transformer networks such as BERT. But in all of this, there isn't usually a sense of time. Now, one exception is the work on semantic change detection, where people have been looking at dynamically involving word embeddings to reflect word meaning changes over time from different time periods. So what we need here is to create the representation of an individual through both their language and their heterogeneous user-generated content over time, where the data streams that contribute to this representation are asynchronous. So the big research questions is how to represent an individual from the heterogeneous content in asynchronous data, and how we vary this representation over time. So another important objective is addressing sparsity in real-world longitudinal data sets while respecting ethical issues in this kind of sensitive data. And there aren't many longitudinal data sets at the moment, but we are in a good position as we have been working in previous work on the creation of such data sets in past projects. And we plan to work with such small fine-grained data sets where we have data from individuals for several months, and we have rich information that includes language, spoken and written, as well as mobile phone data and some ground truth labels. But also we want to work with much larger data sets that we have that come from online platforms, that contain thousands of users and millions of posts over a much longer period, but they are more coarse-grained, and the information we have is mostly posts and network information, and the labels there are noisier. So all of these data sets are sensitive, and we plan to keep them in a safe environment, and we're in the progress of adding annotations in addition to what labels that are already there. And we're also working on generating synthetic data on the basis of the data sets. And this comes with more important ethical issues about how to best represent users and how eventually we would be sharing such synthetic data. And another important objective is the definition of clinically meaningful tasks and quantities to measure over time. And we are particularly interested in identifying moments of change for individuals, and we're focusing at the moment on obtaining ground truths for such moments of change. We want also to create a real-world evaluation setting where, apart from working with the real-world data I mentioned, we co-create with stakeholders and especially clinicians. So we want our tasks to be formulated in a way that they can be used to help the creation of new instruments for monitoring and assessing mental health. And also we want to be able to use our sort of the output of our sensors to create interpretable summaries that summarize moments of change and the evidence behind these. So these are usable by individuals and clinicians. So where are we with all this? So the fellowship only started in December, but we have prior work that has led to it. So I'll talk a little bit about this in the remaining half of the talk. So our work from 2016, our calling 2016 paper, was the first work that actually combined language and heterogeneous user-generated data for a longitudinal task, where the task was that of predicting mental health scale scores at different points in time. So I note that there aren't that many longitudinal tasks in NLP, and so this was the first that actually combined language and other heterogeneous user-generated content. And the method we used at the time in order to combine all of this information was multiple kernel learning. So there's we've made some advances to this, which I'll mention later. So in our ECML 2018 work, we explored appropriate settings for evaluating longitudinal predictions in mental health. So in our 2016 paper, our concern was mainly the fusion of language and other asynchronous heterogeneous content. So how to do that. But in our 2018 paper, we were also interested in what makes a good evaluation setting for real-world deployment. So currently, for longitudinal tasks, particularly in mental health, and not just NLP and mental health, I mean all of the longitudinal tasks in mental health, there are three popular evaluation settings. One is leave one user out cross-validation, where the data of a particular user is left out just for testing, and we never see this user in the training. There's the leave one instance out cross-validation, where which is essentially an intra-user evaluation, and we see we basically alternate between an instance from this user's data that we use as testing. And then the most popular setting is a mixed evaluation setting, where you see data from the same users in both training and testing. Obviously not the same instances in training and testing, but you see the same users in both training and testing. So in a mixed setting, we will have seen data from the same users in both training and testing, as I just mentioned. And now we showed that actually there is a problem with this popular setting, because rather than explaining the predictions based on different instances, we are actually capturing we're actually capturing users, because all instances the tendency is for instances from the same user to fall within a specific range. And so if we then moved to look at an intra-user evaluation setting, and we looked at the R-square, the variance of the dependent variable explained by the dependent variable, where here the dependent variable is the mood score, we would see that sort of the variance would be the variance of the dependent variable explained by the independent variable, where the independent variable is all of the other data we have about the user. We would see this is below 0 for within user instances. So this means essentially that models don't generalize well across users. So this work also revealed issues with the leave one instance out cross-validation setting. So a lot of research in this space uses a sliding window in this leave one instance out cross-validation, where you essentially report better results. So this is, you look at the left part of the slide and the top bit, where larger windows essentially mean, larger sliding windows means better performance. And what, rather than this being because we have more information about the user in general, and that helps us make a better, helps the model build a better picture of the user, essentially what it is that we actually have test instances creeping in within the sliding window. So we have to make sure that this doesn't happen. So essentially what we need to do in the future is optimize model performance for leave one user out cross-validation, where actually currently models don't perform well. So, so more recently, we've been working on the user representation learning, and this, if you remember from earlier in the talk, what this is a really important prerequisite for all of the other tasks. So how you represent a user from the language and heterogeneous user-generated content, and have this vary over time. So we experimented both with window-based settings and dynamic settings. So in the window-based setting, representations are learned independently in different time windows, and this is a paradigm that we also see in the area of semantic change detection. Whereas in the dynamic setting, the idea is to have a dependency between the representations so that they're learned jointly at the same time, or they vary together. So for our window-based user representation learning, we used a variant of skipgram with negative subsampling to train user embeddings, and we considered non-textual data from our Warwick NYU dataset from the Collin 2016 paper. And here it's a sort of a slightly different way of thinking of a sentence, where we actually consider a sentence, or an instance, to be consisting of any features encountered in a particular instance. So, for example, all the sort of Wi-Fi settings or mobile phone use or accelerometer information we have for an individual. And having learned embeddings in this way, we aim to replicating learning mood scores as in our Collin paper. So there's two ways one can test the effectiveness of these embeddings. One is using them in a semi-supervised or supervised task, and the other one is actually looking at alignments between the embeddings learned. So here we actually saw that results in the difficult leave one out user cross-validation setting were not great, but we're still experimenting on actually improving the kind of representation, also looking at contextual embeddings and multimodal contextual embeddings. So our dynamic setting that we've explored was using RNN encoders and decoders to learn temporally sensitive user representations, treating user changes in the user as an anomaly detection task. And here the idea is that the representations where the model makes the largest error in learning these representations are those with the largest change. And we present three different settings. One is a reconstruction of the user sequence of the representation of the user, predicting future representations, and combining the two. And so far, we've evaluated these models for semantic change detection using both real and artificial data. And we're also starting experiments with user representation learning. However, here we have to work on the ground truth, on obtaining also the ground truth of what constitutes a moment of change for a user. So as future steps, so we plan to work over a number of different tasks over the course of the fellowship, and this is the really nice thing of having a 5-year project to work on. So apart from the different kinds of representations, we also plan to work on time-sensitive fusion, data generation, and privacy, detection of normal states and anomalies, which we already have started working on, and longitudinal predictions, and also creating interpretable summaries from the kinds of moments of change we automatically detect, and context around them. So I also have a Turing blog about how this project could help with situations such as the current pandemic. And finally, I'd like to mention my great research team, without whom all this work would have not been possible. And Adam and Federico are the people currently working with me on the fellowship. We're expecting to recruit students for October. And we're working on a number of related tasks in NLP and NLP applications with my other PhD students and postdocs. So thank you very much for your attention, and I look forward to your questions.
Thank you very much, Maria. We just have time for one very quick question. We just have 1 minute left. So if anyone wants to ask Maria, well, we don't have time, but maybe one quick question. Or
Sophia,
again, yeah.
Sophia, have you got the Google Doc? There's a question in the Google Doc.
There is one, but it's not a thing for, hang on, Maria, it's for Ivan. And it's, but basically, well.
No, there's some for Maria there.
Oh, hang on. Yeah, okay, it's Alex, sorry. How can you, sorry, Maria, how can you remain sensitive to rapid versus gradual shifts in behavior? And can you implement a dynamic time window in your RNN predictions? Hang on, there's more here. Yeah, that's the question.
So this is about distinguishing between rapid changes and more subtle changes, if I understand this correctly, and also. So what was the other part of the question?
Sorry, I'm just going back.
And how these RNNs can be dynamic, how the work with these RNNs
can be dynamic.
So I'll answer the second question first. So with the current models, the embeddings are not at the moment learned jointly. The dynamic part comes from the fact that they are that essentially they're changing. There is a sequence in how they're changing. So there is a dependency in basically how. So we're working with pre-trained embeddings in this case, but what we're having is that basically all the previously learned word embeddings are influencing the rest. So essentially it's a sequential model, and sort of the effect of the change happens sequentially, which is something that has not been the case with semantic change detection so far. And at the moment, we've done experiments on sort of, I think it depends now on sort of the type of data and ground truth, whether you can capture subtle changes or more whether you can capture subtle changes. So at the moment, I'd say that, yeah, we don't have enough of the evaluation on both to be able to say how well we capture the subtle versus the sort of the more obvious changes. But yeah, that's a very good point.
Okay, thank you very much, Maria, for your time.